For thousands of years, coastal West Africans have fished the sea to make a living. But 4,000 years ago, a deadly disease arrived here, bringing death and misery. Its name, malaria. That people continue to live and fish here today demonstrates the power of evolution. Power felt in the widespread effect of just one mutation in a single gene. Malaria is caused by a tiny parasite carried by mosquitoes. Humans become infected with the parasite through a mosquito's bite. It may take just a few short weeks for the parasite to destroy a human's red blood cells, necessary for spreading oxygen throughout the body. A red blood cell is invaded by the parasite, which soon multiplies, causing the cell to burst. These new parasites are now free to invade yet more cells. In West Africa, malaria is so common that most children are infected with the disease. Though many suffer symptoms severe enough to warrant trips to the hospital, like this one in Senegal, for most the disease is not fatal. The key to their resistance is in their genes. Dr. Ronald Nagel studies the genes that make hemoglobin an essential part of red blood cells. Genes are all paired, with each parent supplying one half of each pair. If either hemoglobin gene undergoes a mutation, the hemoglobin it makes will be changed. This particular mutation, called the sickle cell gene, is tiny. But it's enough to change the shape of the hemoglobin molecules it makes.
People that had one copy of the gene were able to survive their infection, their malaria infection. They would not die of it. Hence, they were able to grow up, get married, have children, and pass the genes on to the next generation. This is selective pressure. That gene had an advantage in that particular environment for those carrying it.
We all have lots of small gene mutations. Mostly they go unnoticed. But if the environment changes, one of them may suddenly show unforeseen effects, good or bad. In this case, one copy of the gene is beneficial, but two can be disastrous, as Fatou and Sheikh Assar found when they started a family. Both Fatou and Sheikh are protected from malaria because they each have a single copy of the sickle gene. Their children each had a 50% chance of receiving one single copy of the mutated gene. Or 1 in 4 might get both parents' normal genes, leaving that child unprotected. Another 1 in 4 might inherit both sickle genes. And that is the case for their daughter Fatou, named for her mother. Because she inherited both copies of the sickle cell gene, all of Fatou's hemoglobin is adversely affected, not just half. Her molecules turn into rigid rods that provoke sickling of the red blood cells, even in the absence of malarial parasites. The slightest exertion can cause a sickling emergency. Her cells sickle one after another, causing blockages in her narrow blood vessels. Fatou's blood flow is cut off, and she experiences agonizing pain. The sickling caused by the mutation led scientists to name this disease sickle cell anemia. Fatou's life will be far from comfortable, but medicine can help her survive this debilitating disease. Though the sickle defect was a mistake, causing great harm to some, for others it is priceless protection against malaria. This is how evolution works. Mutations occur at random and may or may not have positive consequences.
The more diverse people are, the more likely that population is going to survive, even to things that might come in the future, infections that we don't know about now. Some people might be, by chance, more resistant to that future infection that might wipe out a population. If everybody's the same, if everybody has the same genetic background, a population can be easily wiped out by a single plague.